In this section, we talk more about equations of lines. The goals. Number 1, let's find the equation of a line given a point on the line and a slope. Number 2, let's find the equation of a line given 2 points on the line. Number 3, we're going to find equations of parallel and perpendicular lines. Number 4, we're going to solve applications. In the first example, we have find the slope of a line passing through 0, -7, and suppose the line has slope 3/2. Now 0, -7 is a very special point on the line. What is it? What do we call it? Yeah, and the way you recognize that is anytime the first coordinate, what we usually call the x-coordinate, anytime that first coordinate or x-coordinate is 0, then you're dealing with the y-intercept, which means from the equation y equals mx plus b, remember we call this slope-intercept form? That means that the -7 is b. And so it's a direct plug and chug thing to find the equation of a line. Just plug in the appropriate slope and the appropriate b value into y equals mx plus b. So we're going to plug in 3/2 for m, right? Because that's the slope. And then the b is -7. So are we going to want to write it like that? It's kind of awkward, isn't it? So what's a better way to write it? 3/2 x minus 7. And I would just keep the answer just like that. So when you're given the y-intercept, super duper easy, and as long as you have the slope, it's super duper easy to find the equation line. Just plug in y equals mx plus b directly. But I mean, it begs the question, what if you have a different point on the line other than the y-intercept? What if you're given 2 points and no slope? Well, we can use a different form of the line called the point-slope form of a linear equation. So let's say you're given x1 and y1 would be a good way to write it. And that's just some point on the line. So x1 and y1, those are subscripts. Those ones are subscripts. And x1, y1 is a specific point on the line, but not the y-intercept necessarily. So it's a specific generic point on the line. And let's say, as always, m is equal to the slope. Then I'll show you where this comes from in a second, but let's write it down. The point-slope form of a linear equation looks like this. You take y minus y1. So, okay, before I write down the rest of it, the first y is your variable y from the linear equation. The second y, the y1, is a number. The first y remains y in your final answer. The second, the y1, becomes a number in your final answer. Okay? Equals m times x minus x1. In your final answer, the x is going to stay x. And the x with the subscript of 1 on it will be a specific number. Okay? That's it. Circle that. This is one of the things you're going to have to memorize, along with y equals mx plus b, which you probably already have memorized. What this point-slope form tells us is given any point on the line and given a slope, you can come up with the equation of a line. Where does it come from? It just comes from the slope formula. So let me show you where it comes from real quick. Let's say you have a line, and your variable point on the line, so this is like x, y. It could, it varies. X and y can vary. But x1, y1 doesn't vary. This is a fixed point on the line. So x1, y1. So variable point, so think of this point as sliding up and down the line. It could be anywhere. I drew it here, but you could draw it anywhere. This point stays put. Okay? Let's find the slope between these two guys. What would the slope be? And I'm gonna write it in a weird way. I'm gonna put the m on the right and the formula on the left. So what do you do to find the slope? You take you take the difference between the y's. In this case, it would be y minus y1, wouldn't it? That's the rise. And then what would the run be? X minus x1. And I don't know if you can see it yet, but that's equivalent to the formula for the point slope form. Because all you have to do is multiply through this equation that we created by the denominator, the entire quantity, x minus x1, and you come up with that. Check it out. If you multiply both sides by x minus x1, on this left side, the entire quantity will cancel, and you'll be left with this numerator. On the right side, you have this. So this formula, this point slope form, comes from the slope formula. Okay? So you don't need, I mean, if you want to not memorize this formula and derive it like this, you can, but this is one of those formulas you use so often, it's just better to memorize it. Okay, so what's the rule? When you're finding the equation of a line, the rule is if you're not given the y-intercept, you use this equation to do it. Some of you aren't going to like that because you've learned other ways to find the equation of a line using y equals mx plus b. But in order to force you to use this equation, that's going to be the rule. If you're not given the y-intercept as your point in the line, use this equation. Okay? Trust me, it's easier. It just doesn't seem easier if you learn the other way to do it first. In this example, let's find the equation of the line with slope 3/4, and let's suppose it passes through the point 1, -5. Okay, so tonight, you're going to be doing this homework, right? To get that formula memorized, you're going to want to write it down. Every time you use it, write it down. Y minus y1 equals m times x minus x1. Just write it down every time you use it, and you'll have it memorized after the third or fourth or fifth time of writing it down, okay? And writing it down is going to help you fill it in as well and solve the problem. So here we're given the slope. Good news, we're given the slope, and we're given our point, which contains the x1 and the y1, like so. So you're just going to plug and chug. If you plug and chug, what do you get for the left-hand side? Y minus, what would y minus y1 be? Well, yeah, but I'll show the step here anyway. So y minus y1 would be y minus a -5, which in the next step will turn into y plus 5, right? We'll simplify it. And that's going to equal, fill it in for me, what do you get? 3/4 times x minus x1 is 1. So I'm just plugging in x1 right there for x. So just so it's obvious what I did, for x1 I plugged in 1. And in for y1 I plugged in -5. Now you do want to simplify it. Let's write that y minus a -5 right away. Let's write that as y plus 5. And then you should be able to solve this thing for y. So let's go ahead and do that. In other words, let's get y by itself. So on the right-hand side, what should I do? Let's go ahead and distribute the 3/4 on the right-hand side. I'm going to solve this thing for y. In other words, I'm going to put it in slope-intercept form. So let's solve this thing for y. Let's distribute the 3/4. Okay, what do I get when I distribute 3/4? 3/4 x minus 3/4, like that. Okay, and now to get y by itself, what can I do? Add 5? Subtract 5, there you go. Subtract 5 from both sides. And the only trouble you run into is you need common denominators. Now remember, your calculator has a fraction button, so you can check your work here. You should do it by hand just so you don't forget how to add fractions together, because you know what? In 10 years, when your little son or daughter comes up to you and says, Mommy or Daddy, how do you add 1/2 plus 2/3? You can't say, oh, you pull out the calculator and you hit the fraction button, son or daughter. You can't do that, right? You have to be able to do it, and then that's going to be the moment they realize you don't know everything if you tell them you don't remember, right? You don't want that to happen. So on problems like this, do it by hand, and then you can check it with the fraction button on your calculator, right? So what do we need? Well, okay, left-hand side, easy. We get y equals The 5 plus the negative 5 makes 0. And then we get the 3/4 x. That stays what it is. Then we have to combine these guys together, right? Negative 3/4 plus negative 5. You can think of it as, what do we need to combine fractions using addition or subtraction? What do we need? Common denominators. Don't need it for multiplication or division, but we needed common denominators for addition or subtraction. So you can think of this 5 as 5 over 1, right? So we've got negative 3 over 4, negative 5 over 1, if you include the negative. What's the common denominator? 4. So we multiply by, what do we multiply by? We multiply the negative 5 by 4/4, and what does it become? Negative 24. So it's these guys then. You combine the numerators, keep that common denominator. What do you end up with? So negative 23, negative 3 plus negative 20, negative 23. I'll put the minus out front as the negative as a minus out front. Negative 23/4, like that. Okay, and then, if you're not comfortable with fractions, just go negative 3/4 minus 24 on your calculator, or minus 5 on your calculator rather, and then hit the fraction button. It'll turn it into negative 23/4 for you. But do it by hand so you don't forget how to do it.